Welcome to this explainer. Looking back, the archives of DD Kashir's Krishi Darshan broadcasts are just an absolute goldmine of agricultural evolution. Today, we're diving deep into this fascinating retrospective, breaking down its most compelling, tech-forward insights into modern agronomy. We're looking at this really brilliant synthesis of history, broadcast education, and cutting-edge science. Throughout this explainer, we'll track exactly how advanced tech is actively revolutionizing cultivation practices, literally shifting farming from an art based on historical intuition into a highly optimized, data-driven science. And the coolest part? It's all been documented through decades of these special broadcasts. So think about this for a second. How exactly does high tech actually hit the dirt? It is a genuine puzzle when you stop and think about it. We frequently hear about these abstract, highly complex tech concepts, right? Things like Internet of Things soil sensors, drone-based NDVI imaging, or automated irrigation algorithms. But how do those complex laboratory-born ideas actually translate into the physical, messy reality of real soil? And, maybe more importantly, how does that technology ultimately end up impacting the supply chain and the actual food that sits on our dinner plates every single night? Well, that is the exact journey we're tracking today through the lens of the Krishi Darshan archives. Let's jump right into our first major theme, the new farming frontier, exploring modern cultivation practices. And right at the very heart of that frontier is the precision farming revolution, where high-tech really hits the fields. Okay, so as a quick foundational reminder, precision farming is basically the use of advanced technology to optimize cultivation practices and maximize agricultural yields. But what the Krishi Darshan broadcasts reveal is the incredible depth behind that definition. We're no longer relying entirely on guesswork or traditional calendars or, just hoping for good weather. The retrospective highlights how modern farms are integrating IoT sensors directly into the soil to measure real-time NPK levels, that's nitrogen, phosphorus, and potassium. And they're transmitting that data continuously. We are talking about automated drip irrigation systems that actually sync up with satellite microweather patterns to deliver exact water quantities at the precise moment the root system is most receptive. This is a massive shift. It means taking the exact same plot of land, the exact same soil profile, and getting significantly more out of it simply by being hyper-accurate and entirely data-driven in how we cultivate. To truly wrap our heads around this leap in agricultural innovation, we have to contrast traditional, localized farming practices with these new precision solutions. Traditional cultivation historically relied on broad, uniform applications. It meant treating an entire 100-acre field the exact same way based on legacy methods, broadcasting seeds evenly, spraying blanket fertilizers, irrigating on a fixed schedule. Precision farming flips that entirely on its head. It introduces incredibly specific micro-level management. The broadcasts detailed practices like variable rate seeding, where planting equipment adjusts the depth and density of seeds on the fly based on a topographic map of the field. And instead of blanket fertilizing, drones equipped with multispectral cameras fly over the crops to identify exact patches of nutrient deficiency. That allows for targeted nutrient delivery before the human eye can even see the plant stress. We're moving from a macro-level, one-size-fits-all approach to a highly calculated inch-by-inch science. Which shifts us seamlessly into our next vital topic, spreading tech awareness and making innovation accessible. Because let's be honest, technology is completely useless if the people who need it most don't know how to use it. Accessibility is the core, reoccurring theme throughout the entire Krishi Darshan archive. The broadcasters recognized early on that having the most advanced precision farming tools in the world literally means nothing if that knowledge just stays locked up in an agronomy laboratory or an academic white paper somewhere. It doesn't help the farmer, and it certainly doesn't feed the population. The strict dedication of this broadcast series was to take these highly complex concepts and democratize them. And they did this by translating dense scientific data into regional dialects, doing physical, in-the-dirt demonstrations on the broadcast, and breaking down sophisticated algorithms into actionable daily advice. It has always been about empowering the viewer with usable, practical knowledge. The true brilliance of the broadcast was its role as an information pipeline. It functioned as this absolutely crucial translation layer in a three-step journey. First, the incredible high-tech precision methods are developed and tested in the laboratory and research phase. Then comes the vital bridge, the Krishi Darshan broadcast itself. This is where the science is unpacked, localized, and turned into accessible mass education. And finally, because of that broadcast, the knowledge lands directly in the farmer's field. It's an incredible, seamless journey where agricultural education travels directly from the researchers, straight through the television medium, and right into the soil where it actively alters cultivation realities. Now, let's zoom in a bit from those macro concepts to a really specific micro case study. Spotlight, Jammu and Kashmir, conquering challenging geography. The broadcast script notes that adapting technology to challenging geography has been a milestone, and man, is it ever worth reflecting on what that actually means in practice. I mean, implementing precision farming on perfectly flat, predictable, standardized land is one thing. It is an entirely different puzzle to bring high-tech cultivation into a region renowned for its intense physical demands, high-altitude microclimates, and terraced farming complexities. This milestone really captures the sheer human ingenuity required to successfully farm in such demanding environments. It's a complete celebration of agricultural resilience and technological adaptability coming together. When you actually have to figure out how to deploy fragile soil sensors on steep inclines that experience drastic temperature swings, you are pushing the absolute limits of ag tech. To really appreciate this achievement, we have to look at the specific hurdles of Jammu and Kashmir's landscape. The rugged terrain actively fights back against traditional heavy machinery, making standard automated tractors nearly useless. Extreme climates mean a sudden, localized frost could literally wipe out an entire apple orchard overnight. And physical accessibility issues make simply transporting heavy technological infrastructure a massive logistical nightmare. But precision farming solves these specific hurdles brilliantly. For instance, instead of heavy ground machinery, the broadcasts highlighted the use of agile, drone-based spraying systems that easily navigate steep inclines and replace dangerous manual labor. To combat the extreme climate, localized weather nodes are deployed to provide rapid, localized frost alerts directly to a farmer's mobile device, allowing them to activate protective measures in time. And remote diagnostics solve the physical accessibility problem by letting agronomists assess crop health from miles and miles away. The fact that precision farming can be adapted to thrive here proves that the implications for global agriculture are truly limitless. This brings us to our final section. The future is now, agriculture's ongoing evolution. There's a line from the broadcast that just perfectly encapsulates everything we've explored today. The future of agriculture isn't on the horizon, it is already thriving in our fields. This is such a powerful and grounding reality check. As focused learners, it's so easy to get caught up reading about what might happen in the next 10 or 20 years, imagining this far-off future of fully autonomous farms. But the Krishi Darshan retrospective proves that this technological revolution isn't just a distant promise or science fiction. Through the pipeline of accessible mass education and the adaptable power of precision tools, these advanced technologies are a present-day reality, actively working in the dirt right now to optimize yields and secure our food sources. So as we wrap up this explainer, I want to leave you with this final provocative thought. How will agricultural tech reshape your dinner plate tomorrow? We've tracked the fascinating journey from the lab, through the vital translation of the broadcast, all the way to the rugged terrains of Jammu and Kashmir. We've seen how precision farming utilizes IoT data, drones, and variable rate technology to turn traditional cultivation into a highly optimized science. The innovation is already out there. It's thriving in the fields, producing the very ingredients you rely on every single day. As this tech continues to evolve, become even more granular, and spread to more farmers across the globe, how do you think it will change what we eat, how we eat, and how our world sustains itself? It's a fascinating question, and for sure one I hope you continue to explore.